Hello everyone, welcome to another IEP physics video. Today we'll be talking about several sample IEA research questions and we will evaluate them regarding how good they are and what to be careful of in each. So first of all, we have a research question pertaining to mechanics, projectile motions, specifically the Magnus effect. And it reads, to what extent does rotational velocity affect the horizontal travel distance of a basketball in freefall? Now, one comment I would like to make here is it doesn't have to be a basketball. If you use a lighter object, the effect will be more noticeable. In fact, if you use a cylinder of paper, the cylinder of paper will experience the Magnus effect to a greater degree and will be deflected a lot more. Now, with that in mind, in order to understand what the Magnus effect is and how it affects the projectile motion, first of all, you have to apply gravitational forces, you have to apply air drag, and you have to calculate the Magnus force, right? Now, this is a pretty good IEA to do. It's relatively simple, right? We have the materials all around us. You can use any ball you need. You can use cylinders. You can use any material. One thing is, of course, it's not in the IEP physics syllabus, but that is important. It should not be. It's a little bit beyond, right? But one of the problems here is that the mathematics, in order to predict what will happen, could be a little bit demanding. You need to know a lot of relationships we have not learned yet. And sometimes if you just want to find the relationship between horizontal travel distance and the rotational velocity, what you might find is that the relationship is not exact. So there's a lot of different factors that will affect it, including initial velocities, etc., etc., etc. So be very careful with this. You have to design your experiment with a lot of planning and with a lot of considerations on what you're going to measure and what factors are involved. Okay, number 2, we have a research question that involves mechanics, fluid resistance, and viscosity. So you could do fluid resistance in terms of like same as air resistance, but it's more noticeable in a fluid. And one of the more viscous fluids you have available to you is either dish soap or syrup. High fructose corn syrup is very viscous. And since it's already a very high concentration of sucrose, you can add water to dilute it and measure the concentration. This involves you being able to do the concentration calculations, which shouldn't be a lot of a big deal. It should be relatively easy. But the method of measuring viscosity is very particular. You have to test it out. You have to research it in depth to be sure that you are measuring it correctly. So, what is evaluation? There are a lot of challenges when you try to do this experiment. For instance, if you want to measure the viscosity, there's several different ways. You can make a spherical object drop through the liquid, or you can make the liquid flow through a tube. But depending on what method you use, you might get different results, and you have to know why, and you might actually be measuring different values. Now, second thing is you kind of have to explain how the concentration affects viscosity. So you have to know, kind of look up the mechanism where if you have higher concentrations of sucrose, it makes the liquid more viscous. This is relatively hard, especially for students. It's not something that is just out there. You might have to do a little bit of digging. But it really depends on the amount of critical thinking you put into it and how much research you put into it. So the more effort you put into it, the better outcome you'll get. Now, third research question is related to engineering physics, which is part of the options in the IB: rotational motion, torque, and the moment of inertia. This is a concept you probably have not seen before. So you have to learn a complete different branch of physics that's similar to mechanics, but it's also very challenging for a lot of students to understand. Be very prepared to invest a lot of time in learning how to use these concepts, right? Rotational physics is not for everyone. If you don't have the time or you don't want to put in the effort, you probably don't want to do this. Okay. And it's one of the things you also will find is that it looks to be deceptively simple, right? But it gives you also the opportunity to show initiative and creativity. There's a lot of different experiments you can do. For instance, here it says in biggest investigation how the moment of inertia affects the final velocity of a cylinder rolling down an inclined slope. So normally if you have an object going down a slope, you only think about gravity. But if it has to rotate, there's different things you have to consider as well. The research is pretty much straightforward. It's in every textbook. The rotational motion mechanics are very easily available online. You have a reasonable control of the variables, so it's easy to control. And the relationship between final velocity and the different variables is very, very tidy, let's say. There's always going to be an equation that allows you to predict what's going to happen. This next research question is related to thermal physics, in particular specific heat. And it asks, to what extent does the salt concentration of water affect its specific heat? Now, one thing you have to be aware of is a lot of students think they can just go into this research question and experiment without having to do a lot of research, and they are totally and completely wrong. For a teacher, it's always apparent how much research and effort you put into this experiment. If you don't put the time and effort, it will show in your explanations, it will show in your data, it will show in your results. So not only do you have to know what specific heat is and concentrations, you have to kind of think critically on how the concentrations will actually affect it, research the interactions, do some calculations beforehand, and give a lot of theoretical background. Now, the challenge here is in providing insightful conclusions. Why does it happen this way? It's how did you build the model? What were the assumptions? Right? Scientific data is very readily available. It's everywhere. The specific capacity of seawater is thoroughly researched. You should be able to find comparisons without any issues. But the important thing is not that you actually do this experiment, you have to be able to interpret and justify it when you get the result. Okay, next research question that we have here is also thermal physics, but more on ideal gases. And it says, to what extent does the rate of non-adiabatic compression of a gas affect the final temperature? Basically, when you have a gas and you compress it, it heats up, right? How fast you compress it kind of dictates what the final temperature will be because of how the heat tends to dissipate. It's related to thermodynamics, it's related to energy, it's related to mechanics. By itself, this is not a very good research question to do your IA on, but it's a good starting point. You should do more research. You should research what factors affect it and what are the possible experiments, and then you'll kind of refine what is good or how you can perform this experiment. A lot of things you have to decide include which type of gas. Normal gas, atmospheric, is a mixture of oxygen and nitrogen. It behaves differently from, let's say, methane. You might not want to compress methane too fast because if you mix it with oxygen, it will explode. It depends on the types of containers. Different types of containers will dissipate heat at different rates. And the focus could be shifted to the properties of the gas in the container if you so wish to do so, instead of trying to do it on just the rate of compression. The final evaluation of this research question is that there's a lot of research papers and there's a lot of resources available online. So you don't have to do all the mathematics yourself, but you still have to be able to understand it to some level. Next, you have to be able to comfortably graph and interpret the data that you have, which is a little bit challenging for some students because you have to make up your own methods to do so. If you're still interested in waves, you can do light waves and you can do experiments on polarization and the Fresnel equations. And this research question reads, to what extent does the angle of incidence of plane polarized light affect the reflectivity and transmissibility? So as you will know, light is reflected and transmitted on the interface of two materials that have different indices of refraction. This means you have to understand the nature of electromagnetic radiation, polarization, and something called the Fresnel equations, which are not simple. They're not impossible to understand, but you will need to spend a lot of time trying to understand the different equations that are involved. Now, one of the hurdles you'll encounter is that this particular experiment requires very specialized equipment. You also need to have a very good eye for detail and good control of the variables, because very slight variations of the control variables will change the result by a lot. Now, we go into the electricity and magnetism, and one of the things you learn in chapter 5.3 is internal resistance. So you can have research questions such as, to what extent does temperature affect internal resistance? How sensitive are internal resistance of different batteries to temperature variations? Or to what extent does temperature affect the total energy available in secondary cells? So in this case, you would just be testing, of course, batteries or rechargeable batteries. But how you do it determines how good your results are going to be. You have to know about resistivity. You have to have a basic understanding on how batteries function and work. And this means you might have to dabble a little bit into chemistry side. You have to know what the materials inside the particular batteries are. And when you do the test, you have to be able to very carefully control the temperature and how this temperature affects the materials. Now, the components of batteries are very easily available. You can just go in the store and buy them, right? But measurement and the relationship between the variables is not immediately apparent. You're going to have to do a lot of research to kind of get the results that you need. Related to electricity and magnetism, we have magnetic field permeability. You can do an experiment to confirm the relative permeability of air by varying the current of a solenoid and measuring the resulting magnetic field. Of course, you would need to have a deep understanding how magnetic fields are measured, and the equations you need to have to calculate and predict the magnetic field strength at a specific point. And you have to have done a lot of research on how to measure the permeability of free space. So I've seen different experiments attempt this. It's always been a challenge for the students because they always skip some variable, or the design of the experiment is not up to par to IA standards. Always remember, because of this, you will need to do a lot of research so that you don't make mistakes. And making mistakes in this particular experiment is particularly bad because the data would be very bad. But one good part of this, or an advantage, is that there's a lot of opportunities to compare the results that you have, because, of course, magnetic field permeability is something that is extensively researched. The last research question we'll be talking about today is related to electromagnetic induction, and in generators in particular. So it reads, the investigation of the effect of wire gauge on the efficiency of electric generators. Now, you may have studied this before, and you know that the resistance of the wires may play a part in the efficiency, but it's not the only part it plays. There's a lot of different factors involving the efficiency of generators, and you have to very carefully consider this and research them so that you don't make a mistake when you do the experiment. You have to know the basic mechanics of generators, in particular how to make them or how to get one if you won't make it yourself. What are the different types of generators? And you have to understand what is the sources of inefficiencies related to how they are built. Now, this will not be an easy IA. It's not easy to measure. It's not easy to build. It is not easy to research. There's a lot of things you have to understand. The field of generators is very large. But one thing you can do is that whenever you do an experiment that is really common amongst other students, you have to be really good at it in order to get a good score. You have to outshine everybody else. But if you make an experiment that nobody else does, it's a lot easier because you don't have to be better than anyone else. You just do the best you can. Now, one caveat here is that it's going to be very difficult to get all the equipment and materials necessary, and there's a lot of DIY involved, so you might be a little bit careful with this. So, in conclusion, it doesn't really matter what topic you choose or what research question you choose. What only thing that matters is how much time and effort you put into the research. As long as you know what you're doing, as long as you have researched the methods, as long as you have looked up the factors involved, you should do okay. Always remember that no matter if you do the same experiment as next student, your experiment is going to be slightly different just because you chose different materials and different methods and different measurements and different equipment. Even if you have the same topic, there's a lot of different experiments you can do with exactly the same equipment with exactly the same topic. It can vary a slightly different variable. It can vary a different way. You can use different materials. There's always a way to make it different. Well, that's all for today. Thank you for watching and see you next time.